Well, I'm gonna talk about this morning. I'm gonna talk about smart cities and what Libelium brings to the market for the IoT in this specific application. So, well, a little bit of background of what we do and who are we. So Libelium is in the market for 14 years, and we have proven our technology through the third generation of products that we are nowadays. So we have been focused in developing a hardware that is focused in to bring to the market a scalable technology and easy to install and maintain. When we are talking about hardware, this is a very important key fact. Also, a technology that has been integrated with different communication protocols, XP, LoRaWAN, Sigfox, 4G, Wi-Fi, narrowband are most of the technologies that has been integrated, and this allow us to go to the market to different projects with different needs. Also, our technology is fully certified, which allow us to go to more than 120 countries nowadays. Well, this is our vision. This is how Libelium sees the world, a world full of sensors, sensors in the cities, sensors in the fields, in the water, in the industries. So sensors gathering tons of data. This data that then is analyzed and converted into great and useful information for us to make decisions. Waspmote is our microcontroller board, which has 7 analogs and 8 digital inputs, which make it any platform because we can integrate any sensors in it. We can send information wirelessly through any communication protocol and send this information to any cloud. We do not manufacture sensors, we integrate sensors from the market into our platform, and that allows us to go to any kind of application, not being focused in just one vertical, but in many, like agriculture, parking, environment, and so on, that we will see later. This is the architecture of an IoT project. We see sensors gathering data, sending information wirelessly to a gateway, and from there we send information to our local database, or we send it to a cloud for the analysis and process of the data. So I think all the hardware manufacturers, we have here the challenge of designing our devices for being easy to use and managed by the users. And in this aspect, the interoperability is the key, and is what we follow and achieve. And I'd rather see this picture in 3 main blocks, which will be data acquisition, data transmission, and data analytics. Well, Libelium takes care of data acquisition, all the sensors taking this information of different parameters and sending the information to a gateway. From this gateway, we send information to internet, and it's where our software partners provide the analytics and the dashboard that really gets the data into information and makes the whole IoT project useful for the end customer. This is our offer to the market. We see in the middle of this slide, we see Waspmote board, and on the left-hand side, we can see the black box, which we call Plug and Sense. Plug and Sense is the encapsulated version of our Waspmote board. So inside we have Waspmote plus a rechargeable battery that we can use with a solar panel. Also, we can, well, in case that the project has access to a source of energy, it can also be recharged by the USB. So we go with these 2 different platforms plus Meshlium. Meshlium as an IoT gateway for XBee protocols, Wi-Fi, and Bluetooth, and also well, 4G, and also a Meshlium Scanner which scans Wi-Fi and Bluetooth signals. Based on this technology, we have brought to the market different models of plug and sense. Each of them is focused in different verticals. So depending on the vertical that we are using, for example, for smart agriculture, we have a model that has integrated sensors related with agriculture projects. Same thing for smart cities or security, or for 20 million pairs, which is a model where we can connect any sensor that has a 420 output. Well, and now we focus on what is a smart city. Well, smart city look for a sustainable growth that allow them to adjust themselves to any economic and demographic changes that are suffering. And for this, technology is a key and is a great help on this. So we must know that over 50% of the world's population lives nowadays in urban areas and cities. And this is something that governments and industries need to manage efficiently and bring help with technology. What a smart city might involve? Well, as we all know, the quality of life of the citizens and the risk prevention as well. Any prevention with fires or floods, storms, all these kind of applications. Also government and public management. As governments, they must improve their processes in public administration. And this more or less give them an argument of their efficiency. Also urban planning, technology, environment, social cohesion, the increase of the social engagement is a key fact for smart cities nowadays. Also mobility, transport, economic, and so on. So I'm gonna tell you about what Libelium can bring to the market, what are the solutions that we have already in catalog ready to use, and then I will focus on 3 of them for this theme of smart cities. So we have ready to use devices that integrate air quality and pollution monitoring, also noise levels or acoustic levels for pollution, waste management, lighting and electricity management, parking, buildings, people monitoring and traffic monitoring through scanning. We will talk about this later, and parks and gardens. So I'm going to be focused, first of all, I will talk about air quality and pollution. Secondly, about parking, and finally about people monitoring. So let's start. Air quality monitoring. This is Plug and Sense, our device that I already explained. We can see in this picture that it has 6 different sockets, A, B, C, D, E, and F. And these sockets are the ones that allows the device to connect 6 different sensors. So we have a node that allows 6 different parameters to be connected at the same time. All this information is being sent wirelessly through any communication protocol that we have integrated, and being rechargeable by a solar panel, as we can see in the picture of the node that is placed on a lamppost. Focusing in our Smart Cities Pro model, we have integrated over 20 different sensors that we must combine in order to have the configuration of a maximum of 6 sensors in the same node. Noise, we can connect to this. Also particle matter, PM1, PM2.5, and PM10, and over 10 different sensors, calibrated sensors. All these sensors are electrochemical sensors, and they have a very low consumption. They give the data in ppms of gas concentrations in the air. Also, we can add luminosity and ultrasound that for some applications are very useful sensors. Now I'm gonna tell you about a real story. In this case was a case study made in Glasgow, where Sensis, one of our clients, were developing a portable system based on sensors networks to monitor air quality. So basically, they wanted to place a suitcase on the top of a van with some air quality sensors inside. Mainly the air quality index node has NO2, O3, and particle matters sensors. And they had a suitcase where air could go through it. Sensors were gathering, sensing these parameters and sending the information through XP802.15.4 into a sensor hub in the same vehicle. From there, they send the information into their own cloud platform where all the data was analyzed. This van, this car, was going around the city, so in this way, they could manage and monitor the air quality of different areas or neighborhoods of Glasgow. See, we can see two pictures of the real deployment. We can see the suitcase with plug and sense, all the sensors connected to the sockets that we saw previously, and well, this was the deployment. Secondly, I'm going to talk about smart parking. Smart parking, our smart parking node has a double sensor, radar plus magnetic. We are talking about the IP68 enclosure, fully certified and with a non-rechargeable battery. In this case, we are going with a non-rechargeable battery, but we are going with LoRaWAN radio, which, as we have explained in previous presentations, is a low power consumption radio and long range, so it makes it perfect for this kind of application. It has dual sensor radar plus magnetic. It allows us to do the remote management, and the battery life we estimate between 5 to 10 years. This depends on the configuration of the node, how we program it, as it has some sleeping time that we can configure. Also depends on how often the node is sending the frame to the LoRaWAN base station. The node will send the frame every time that the status changes. So as much or as often the status changes, more often frames will be sent, and therefore the battery consumption will be affected by this. Where we can install these parking nodes? Where? Well, obviously in urban areas, city centers, but also in places such as shopping centers or airports, hospitals, sports and entertainment centers. In general, at any place where it is required directions and accuracy to drivers. The benefits of deploying a smart city pollutions are obvious. Mainly, I want to focus in some of them, reducing gas emissions. This will affect to pollution levels and environmental monitoring. Also reduce traffic congestions. And this affects not only to our fuel consumption and our pockets, also to the anxiety that population gets when it's trying to find a parking spot for longer than 15, 20 minutes, half an hour, depends on the city. So in terms of figures, a smart city solution can reduce 43% the time spent looking for a parking spot, which I think is a lot. Also 30% of the kilometers we travel trying to find one, and 8% the traffic volume, and 40% the gas emissions. Our smart parking solution comes already programmed from factory, and we just need to configure it. We provide a device application where customer can configure the time settings, the night mode, and other parameters to get the configuration more suitable for their project. Talking about real stories, this is a smart parking case study. In this case, was deployed in Italy, in Varese. The main challenge here was to create a more efficient method for rechargeable electric cars. In this case, they placed 7 different smart parking nodes, and this method allowed them employees to wait and to create a queue, a virtual queue, and this was mainly it improves a lot the efficiency of these rechargeable stations. This is the real picture of the deployment on the customer. We can see the nodes are placed on the middle of the car spot. This is important because it's where any vehicle has the biggest amount of body, and therefore the radar sensor accuracy can go up to 99%. Finally, a smartphone detection. Our Meshlium Scanner device scans Wi-Fi, Bluetooth, and Bluetooth low energy signals. This means that it's capable to detect any device that is emitting these signals without the need of being connected to any access point. This allows us to study people patterns and also traffic monitoring, as we are all nowadays connected to Bluetooth to our car in order to have the hands-free, or our smart watch is connected through Bluetooth low energy to our smartphone, because we have applications about how many steps we take per day and all this kind of application that make us to emit different signals, or well, not us, the devices that we are into it. So it is a great solution for retail market and will allow us to know the customer behaviors and also to know what are the hottest and cold areas of, for example, an airport or a mall center. So we can see what time customers have spent in one area, what time they came, how often they come, or what are the main areas that they are visiting, or how we can redirect maybe some promotion and marketing actions to them in order to well, increase our profits. Well, the benefits, we can talk about shopping centers, as we were talking about retail, public services, medical centers, road vehicle traffic monitoring, and infrastructures. Mainly any place where we want to know more about people and the assistance of them. And as a case study, I want to talk to you about this case study that was in the United Kingdom, in Bolton, in a food festival. So here the customer wanted to monitor how many people were assisting and what were the main areas that people were around. So they placed 2 different Meshlium scanners in 2 poles, as we can see in the picture. And their aim was mainly to know how many people were assisting, but also in terms of security, because it's not the same, the security that a city must provide when we are having a trade show of 20 people than if we are having a trade show of 200 or 500 people. So when we are talking about this kind of events, this is a great technology to detect and to prevent and provide security. These are the pictures, in this case, of Meshlium Scanner in different poles of the area. Well, and this is all. Thanks very much for your attention, and if you have any question, I will be glad to help.